Hello and welcome to all. In previous session we have discussed about the contact and non-contact forces, non-contact forces with their examples and their characteristics. Now in today's session we will discuss about the Newton's law of motion and in Newton's law of motion. First of all, we will discuss about the first one, which is first law of motion. The Newton's law of motion are basically the basic law of physics, which gives the better understanding of motion of any object. In first law of motion, it gives about the information of force and inertia. The first law of motion states that if a body is in a state of rest, then it will remain in that state unless, and if it is in a state of motion, then it will continue moving with the same velocity in the same direction unless an external force is applied on it. It means that an object remain its initial condition or state in the absence of external force. The state is the state of rest, or it is the state of motion with uniform velocity. In both cases, the object has tendency to maintain its initial condition or state. With the statement of first law of motion, we have got a term inertia. Basically, inertia is the property of an object by virtue of which it neither changes its state nor tend to change the state is called inertia. It is of two types: inertia of rest and inertia of motion. Inertia of rest is if a body is at rest, then it will continue to remain at rest unless an external force is applied. And inertia of motion is if a body is in a state of motion, then it will continue to move at same speed in same direction. It means motion with constant velocity unless an external force is applied to change its states. These two inertia is included in the statement of first law of motion. Again, if we want to read out the statement of first law of motion, it states that if a body is in a state of rest, then it will remain in that state, and if a body is in state of rest, this condition represent the inertia of rest, then it will remain in that state. And if the body is in a state of motion, this state of motion represents the inertia of motion. If a body is in a state of motion, that then it will continue moving with the same velocity in the same direction unless an external force is applied on it. Then we have got the information about inertia from the first law of motion as well as term force. Force is also included in the statement of first law of motion. Here, force is an external cause or external agent which change or try to change the inertia of an object. This inertia may be inertia of rest or inertia of motion. Thus, we have got information about inertia and force from the first law of motion. Now we have to discuss about some examples related to first law of motion. The first example: if a passenger in moving bus leaned forward when driver applied the brakes, it means that person in moving bus is also in moving condition with the bus, and when force is applied, the bus is suddenly stopped, but the passenger or person in moving bus is still in inertia of motion. Therefore, the tendency of movement of person towards forward, due to which the person bends or leans towards forward in this condition. And second is a person in standing car, that is the car is in rest condition, moves backward when car is suddenly start moving forward. It means that the person which is present in the standing car having the inertia of rest, and when the car is suddenly starts moving forward, the car is in motion but the person is in inertia of rest. Therefore, the person moves backward. The another example related to first law of motion is removing of dirt particles from the blanket or bedsheet. अगर हम बेडशीट को या ब्लैंकेट को कस के झरकते हैं, तो जो ब्लैंकेट है वो सडनली मोशन की कंडीशन में आ जाता है, बट जो डॉट पार्टिकल्स हैं या धूल हैं वो इनर्शिया ऑफ रेस्ट कंडीशन में रहते हैं, जिसकी वजह से वो सेपरेट हो जाते हैं आपके ब्लैंकेट या बेडशीट से. ये भी एक एग्जांपल है न्यूटन्स लॉ ऑफ फर्स्ट मोशन का. Now, with the help of first law of motion, we can redefine the definition of mass. Initially, we know that the mass is basically the amount of matter which is consisted by a body. But from the definition of, from the statement of first law of motion, mass can be redefined as it is a measure of inertia of the body. That is, the greater the mass, greater is the inertia, and thus more is the resistance to change the state of rest or state of motion. Basically, the resistance to change in the state of rest or state of motion is the inertia of the body. Therefore, the mass is the measure of inertia. If a body having greater mass, then we have uh, if a body having mass m1 and another body having mass m2, here m2 is greater than m1, therefore to change the position of the mass m1 and m2, f1 and f2 is required. Because the mass of m2 is greater than mass of m1, then f2 will be also greater than f1. More amount of force is required to change the state of the body having heavier mass. Now we have to learn about the term linear momentum. Linear momentum, the force required to stop a moving body, is directly proportional to mass and velocity of the body. It can be expressed as P. This is the representation of linear momentum, which is equal to mass into velocity. It is a vector quantity because it is a dot product of mass into velocity. Mass is scalar and velocity is vector. Therefore, the linear momentum is also a vector quantity, and its unit is, the unit of mass is kg and unit of velocity is meter per second. Therefore, the unit of linear momentum will be kg meter per second. With the help of this equation, we can say that if a body is at rest, the linear momentum of the object will be 0. And if you want to calculate or find the change in momentum will be equal to, which is represented as delta p. Delta is representation of change. Therefore, change in momentum will be equal to mass and change in velocity. Here mass will be constant of the object, and the rate of change of momentum is the change in momentum with respect to time. And from this equation we know that the change in momentum is mass into change in velocity. Then change in momentum will be equal to mass into v minus u. Here v is the final velocity and u is the initial velocity upon time. And from the definition of acceleration, we know that the acceleration will be equal to change in velocity with time. Therefore, it can be written as mass into acceleration. Acceleration will be equal to v minus u by t. That is change in velocity upon time. Therefore, we can say that thus the rate of change of momentum is the product of mass and acceleration. In next lecture, we will discuss about the second law of motion, which is related to the change in momentum with respect to time, that is rate of change of momentum. Thank you.